in tabla. The tabla, a percussion instrument widely used in Indian classical music, is designed with mathematical precision to produce a rich variety of tones and rhythms. From drum size to tuning, mathematics plays a key role in shaping its sound. Let's explore the role of math in the tabla. Tabla uses math in drum size and frequency. The larger drum, baya, and smaller drum, dayan, follow wave equations where frequency is inversely proportional to the square root of the drum's radius. Larger drums produce lower frequencies, while smaller drums create higher frequencies. Membrane tension and vibration. The tabla's drum heads vibrate according to Bessel functions, which describe oscillations in circular membranes. The tuning paste chahi, placed in the center, alters the membrane's mass distribution, affecting sound frequency. Rhythmic patterns in mathematical cycles, tabla compositions, or Taals, are based on cyclical rhythms divided into beats, matras. Common Taals include Teen Taal, 16 beats, 4 plus 4 plus 4 plus 4, and Rupak, 7 beats, 3 plus 2 plus 2, demonstrating mathematical symmetry in music. Harmonic overtones and sound quality. The tabla's ability to produce sustained harmonics follows Fourier analysis, where sound waves decompose into fundamental frequencies and overtones. Mathematical principles applied, wave equations govern the tabla's drumhead vibrations. Bessel functions describe how circular membranes oscillate. Mathematical sequences define complex rhythmic patterns. Mathematics is deeply embedded in the tabla's design and rhythm, allowing it to produce mesmerizing beats that blend seamlessly into traditional and contemporary music.